Hello guys, how are you all? Good evening to all of you. So welcome to this live session of Vedantu, and my name is Mridul, and today we are going to study tangents, which is of circles of class 10 CBSE course. Okay, so guys, in this course what we are going to do is basically we are going to understand what is tangent and the concepts and the theorems which are related to tangents, and then after understanding, we are also going to solve problems related to those, right? So let us see what's there. So basically the first thing is what is tangent and what is the difference between a tangent and any other line into a circle. So for example, say this is a circle and say this is the center of the circle. Now there are two lines A and B. Which one do you think is a tangent? Yes, of course, yeah. So of course this red line or this B is the tangent. Now what is the difference between this line and this line? See, this line touches the circle at two different points, right? So this is also known as secant. Now we talk about tangent. So whenever we talk about tangent, that means it will touch the circle, it will not cut the circle. And whenever it touches at one point, right? So these types of lines are known as tangent to the circle. Okay, so hope all of you got what is tangent. Now let us see some important properties of this. So for example, angle between the tangent at point P and a radius which is drawn at this particular point. So what is the angle between them? Yeah, this is very important, guys. Yeah, so it seems most of you know it. Yeah, this is perpendicular and this is always 90 degree, right? So if this side is 90, this side is definitely 90. Okay, so cool. So let's go to the next point. Next is, now suppose I have a point P on the circle. So it's saying we can have two tangents at the same point P of a circle. Is this true or false? That means what it's saying is, say this is one tangent at this particular point P. Can I have one more tangent at the same point? Is it possible? See, I can draw a line at this point, but you see this is not a tangent because this is cutting this point, and it's not possible for me to draw any other tangent at this point. That means this line is false. So I can have only one tangent at a particular point in a circle. Okay, understood? So any point, I'm revising it, so any point in a circle I can have only one tangent at this particular point. I cannot have any more tangents here, right? So every point on the circle will have a particular tangent. So let's go to the next one. Next question is, from a external point P, suppose there is an external point P, okay? Now the number of tangents that we can draw to a circle, how many tangents can we draw from this point to the circle? So option is 1, 2, 3, or D option, that is many or infinite. Yeah guys? Oh, very quick answers. So you know this topic almost. Okay, so guys, first of all, we can draw one tangent here. Of course we can draw this. Let us see if we can draw any more tangents. So this is not a tangent, not a tangent. Yeah, we got one more tangent at this particular point, right? So that means if you see properly, we can draw only two tangents to one circle from one external point, right? So this is the circle and this is the external point, and I can only draw two tangents, right? So the answer will be 2. Got it? Any doubt, guys? Okay, so now next is, let us see what is there. So PA and PB are two tangents to the circle, right? Now they are saying PA is equal to PB. That means the length of the tangent from this point to this A and the length from this same point to the other point which touches the circle is B. And they're saying that these two lengths are equal. Is it true or is it false? This is very, very important relationship. And guys, this is true. Right? So this is this. That means if I join these two lines, I am going to get a triangle that is PAB, and this triangle will be an isosceles triangle, and this complete angle is going to be equal to this complete angle. This is very important, guys. Okay, fine. Now on this particular concept, what we have learned, you can solve few questions. So let us see what type of questions can be solved using this particular technique. So it says a circle is touching the side BC of a triangle ABC at point P. So that means this is a triangle A, B and C, and this side BC is touching the circle at this point P, and touching AB and AC produced, and the other two sides of this triangle ABC I have to produce it. That means I have to extend this side, and when I extend, it touches the circle at point Q, and on this side it touches at R. Now they are saying prove that this side AQ or this length AQ is half of the perimeter of the triangle ABC. Right? So try to prove it, guys. So what they are asking is prove that AQ is equal to half of perimeter. What is perimeter of triangle ABC? That means sum of the length of the sides of the triangle. So AB plus BC plus CA. So this is what they are asking. Okay, guys. So now how will you prove this? So you see, let us take an external point A. Okay. So from this external point A, how many tangents do we have? We have two tangents. So from external point A, we have two tangents, that is AQ and AR. And we have just learned that from an external point, we can draw only two tangents and both of them will be equal. So we know that AQ is equal to AR. Right, AR. So this is my first relationship. So next, I have one more external point, that is B. Now from this external point B, if I try to draw two tangents, so this is, you can see this BP and BQ, right? So I can also say that BQ is equal to BP. This is also relationship number 2. Similarly, from point C, I will have two more tangents, which is CP is equal to CR. So this is relationship number 3. Now, let me see what is the perimeter of ABC. So now, perimeter of ABC means AB plus BC plus CA. And now, AB plus BC plus CA, I can write it in this way. AB plus, so in place of BC, I can write BP plus PC. Understood? So BP plus PC is nothing but BC. So I have just broken this BC into two parts plus CA. So CA is as it is. Now what I will do is I will use this second and third equation. So now I can write AB plus, instead of BP, I will write BQ. So I can write this BQ, and instead of PC or CP, I will write CR. So plus CR plus CA. Okay. Now you see, guys, CR plus CA will give me AR. So these two will give me AR, and AB plus BQ will give me AQ. So from here I can write AQ plus AR. And now we know that AQ is equal to AR. So from here I can write 2 times of AQ. So that means what do I get? So I got AQ is equal to half of AB plus BC plus CA. Or in other words, half of the perimeter of the triangle ABC. So in this way, by using this simple theorem, we can prove or solve these types of numericals. So all of you got it? Yeah? Okay. Now let's see what else can we do with this. Now suppose you can have these types of problems where they will ask, say they will have two lines L and M. Okay? And they're saying that these two lines are parallel. Okay? Now, line L touches the circle at point A and line M touches the circle at point B. Now, the tangent at C, so there is a tangent, so there is a point C where we draw a tangent, and this tangent at C makes an intercept between DE, between these lines L and M. So this is an intercept DE, okay, between these parallel lines L and M. Now what they are doing is they are connecting this point to the center of the circle F and this point E to the center of the circle F. Once they connect it, they are saying that this prove that this is a 90-degree or this is a right angle triangle. How will you do it? Yeah. And this point, guys, this point C can be any point. It doesn't matter which point is this. Okay, so try it. I will try to show you one more different way of thinking about this problem. So by the time you try to solve this, so it's very simple way of explaining, right? So let me show it to you that C can be any point. So for example, now suppose the C is this point. Okay, suppose C is here and say this is my center F. Even now, if I join this and this should be a right angle triangle. So it doesn't matter where my C point is. This is point A and this is point B. Okay guys, now try to apply whatever we have learned with some properties of triangles also. So I hope you know the triangle properties. Yeah, congruency. So try to apply those and try to prove this. Yeah, let me know once it's done. Let me know if you need some hints. So first of all, okay, I'll give one hint. That is, let us join these points. Okay. And now you see if you can see something in this. Okay. So what is given, guys? L is parallel to M, right? So now what to do? Now let us take the triangle and this point is D, right? This point is D, this point is E. So let us take this two triangles, AFD and triangle CFD. So in this two triangle, let us see what is there. So first of all, you see this side is equal to this side. Okay. And this side is equal to this side because D is the external point. So from this external point, I draw two lines. So I can say that AD is equal to CD because this is external. That is what we have just learned, right? So these two parts will be equal. And similarly, AF is equal to CF because both are radius of this particular same circle. and you see FD is common. So from side congruency, we can say that these two triangles are congruent. So if these two triangles are congruent, then we can say that angle ADF is equal to angle CDF. So that means this angle is equal to this. Yeah guys, simple. Yeah. Okay, what else can we do? Similarly, triangle BFE and triangle CFE can be shown that this side and this side are the radius, and this side is equal to this side. So, and this side is common. Similarly, these two sides are congruent, right? So from here also we can show that this angle is equal to this angle. That means, so angle FEB is equal to angle FEC. Okay, now what? So this is 1 and this is 2. Now what? Now guys, we know that L and M are parallel lines, and if we have two parallel lines and there is a transversal, then we know that internal angles, so these two are the internal angles, and the internal angles on the same side of the transversal sums up to be 180. So I can say that angle D plus angle E, okay, that means this angle and this angle is equal to 180, right? And this can be written as angle A. Now D is nothing but ADF and FDC. We have written it here, right? So I can say that 2 times of FDC, because this angle is equal to this angle. So angle D, this angle D can be written as 2 times of angle FDC. Okay guys. Similarly, this complete angle can be written as 2 times of this angle, because these two are in equal parts. So 2 times of angle FEC. So that is equal to 180. That means what? Let me say this is X and let me say this is Y. So that means this X. So that means angle FDC plus angle FEC. If I divide both sides by 2, so I'll get 90 degree here. That means in this triangle DFE. So if you see this triangle DFE here, so suppose this is D and this is E and this is F. So say this angle is X and this angle is Y. So these two angles, if I add, I'm getting 90. So that means what? This angle is also 90. So this is a right angle triangle, right? So that means in this triangle, so from here by angle sum property, we can find out that this angle BFE is 90, right? In this way, we can prove this. So hope you got this solution. Understood all of you? Okay, cool. So now let's go to the next thing. Now guys, so once we have learned this about this tangent, now we need to go to other theorems. Now when you go to the other theorems of tangents, you need to know few more concepts of chords and segments. So for example, any line which cuts the triangle into that circle into 2 parts is known as chords, and there are 2 segments. This is segment, say this is segment 1 and this will be segment 2, right? And the longest chord is also known as the diameter, right? So for example, if this is the center and I try to draw a chord here, this is known to be the longest chord of any circle, and that is the definition of a diameter, right? So let's go to the next thing. Now let us see some properties related to this. So for example, here in this particular question, it says that PQ is a chord. Okay. Now they're saying that this chord makes 2 angles PAQ and PBQ. Now they're saying that PAQ and PBQ are the angles subtended by the same chord PQ on the circumference on the same segment. That means, see here, try to understand this particular line meaning of this. So that means I have two segments. Now this chord can subtend the angle at two different segments also, but here they are saying this is not the case. So here this particular chord subtends this two angles, okay, at the same segment. So when they do that, what is the relationship between this angle and this angle? Yeah, most of you or few of you may know this. So this is for them who does not know it. So this is very, very important. So that's why I am taking this. So for those who don't know, this is very important, guys. And let me tell you, this angle will always be equal to this angle. So it is option A. So I can see few of you know it, but that's fine. So, but those who don't know, this is very important, guys. Okay. And now you see, it doesn't matter where we draw the angle, but one thing is this angle should be at the circumference. So I can draw infinite types of angles here and all of them will have the same angle, but I have to draw it on the same side of the segment, and that too on the circumference. I cannot draw it in between somewhere. I cannot draw it somewhere here and tell that this is, this is equal to this. No, I have this point should be on the circumference, right, guys? Okay, so now let's go to the next concept. Hope you understood this. Now the next thing. Now suppose I have a chord PQ. Now it subtends an angle at the center and it subtends an angle at the circumference on the same side again. Then what is the relationship? So let us say that C is the center and A is the point on the circumference, and now I have two angles PCQ and PAQ, right, from the same chord PQ on the same side of the segment. Then what is the relationship ABC? Yeah, very good. So I can see few of you are giving me the answer. So that means this angle is half of this angle, right? So option A, that is PCQ, is, no, it should be twice, right? So that means this should be twice, of course. So this PCQ is 2 times of this. That means what should be the right answer is PAQ is half of angle PCQ. This is the right answer. Okay, fine. Now, yeah, I'm getting more suggestions from your side. So before I go to this, let me also tell it. Okay, fine. So since a few of you are saying, what about cyclic, quadrilateral? Yeah, guys, if we have a segment, say PQ, and this segment PQ subtends angle on both sides of the segment, right? So say it subtends, so this is suppose P and Q, and this is my chord. Okay, now this chord subtends an angle, say A on one segment and one more on the other side. Okay, one more on this particular side. See, it can be anywhere. Okay, it doesn't matter where it is. Okay, now if I join these 2 points, okay, so these types of quadrilaterals are known as cyclic quadrilaterals, and the property is this angle or the opposite angles or the sum of the opposite angles will be 180 degree. Similarly, this plus this will be 180 and this plus this will be 180. Now this point can be anywhere in this segment. It does not matter. It can be somewhere here also. It does not matter. Why? Because this angle and this angle is same, so it doesn't matter. Okay, now let me go to the next one. Now it says that angle subtended by a diameter to the circumference of the circle is always. Now let me see how many of you know this property. This is also One of the very important property. Yeah, very good. So I can see few of you giving me the right answer. So answer is C. So that means whenever I have a diameter, at that time the angle that it subtends on the circumference on any side of the, so now this, you see guys, this is interesting. Now whether it subtends on this side or whether it subtends on this side, it is going to be 90 degree. Why? Because first of all, this becomes cyclic. So we know that this angle plus this angle is 180. So if this is 90, then this should also be 90. And one more sense is, suppose this is diameter, it divides the segment into two equal parts. So if in this equal part, if it is giving 90, so this part is also, it will give 90. Now you might think, what is the relationship? See guys, we know that angle PCQ is 2 times of angle PDQ. We just saw it here. So this angle at the center is twice that is subtended at the circumference. Similarly here you see, what is the angle at the center guys, or what is the angle at the center here? So angle at the center is 180 because this is a diameter and this is a straight line. So therefore the same chord, which is also the diameter, will subtend half of this 180. Now half of 180 is 90. So either you go this side or you go this side, you will get 90. Now guys, this is very important for you guys to see that it doesn't matter where you go. You can have a angle at any point. At any point, this is also 90. You can go here, you can go here, you can go anywhere, and just you connect it. This will be, all of them will be 90. This is 90, this is 90, this is 90. You can draw infinite triangles in this way. All of them will be right angle. So hope you understood this one. So let me go to the next one. Now this is very important. Okay. Now this is combining all of them, you get one particular relationship which is very important. So it is a relationship between a tangent and a chord. So let me explain this particular situation before this question. So it says, suppose you have a circle, okay, and now suppose you have a tangent at any point. Say this is a point P, okay, say this is a point P. Now I have, suppose, a chord. Now chord, I can take any chord anywhere. Suppose I take a chord in this way. Okay guys, I take a chord in this way. Okay, now say this is PQ. Now what they are asking is, what is this angle? Say this angle, say this point is T. So what is angle QPT? How can we relate this to the angle which is subtended by this particular chord? Now as we learned, let me draw it. Yeah. So now suppose at this particular point, what is the name that I have given here? A. Okay. So let me say this is A point here. Now is there any relationship between this, say this angle and this angle? Yeah. Yeah. What is the relationship? So this is the question. So they're asking, if this is 30 degree, what is the measure of this angle? How will you tell? Yeah. 30. So if this is 30, this is 30. Both of them are equal. Equal. Okay. Let us try to prove this. So it's better to prove. Okay. So what I will do is, guys, now instead of taking this point here, what I will do is I will draw a diameter at this. Okay. So first of all, let me find out what is this angle. So say this is angle alpha. That means angle QPT is equal to alpha. Okay. If alpha is not looking little bit serious, let us remove this alpha and let us say this is some angle theta. Okay, or theta 1. That is better. Theta 1 looks better. So let us say that this angle is theta 1. Now guys, this I am saying, say this is A dash. So now let me say that PA dash is diameter. If this is a diameter, that means what? There is center somewhere here. That means what? CP is perpendicular to PT, because this is the radius at this point. This is what we have learned in the morning at the starting of this class, right? Not in the morning, sorry. So now we know that this CPT is 90 degree and this is theta 1. So what is this angle, guys? So this angle, let me say, is theta 2, and I know that theta 2 plus theta 1 is equal to 90 degree because this is perpendicular. So from here I can say theta 2 is 90 minus theta 1. So this is equation. Okay, now let me see what is this angle. Now just now we have learned that if this is a diameter and this angle which it subtends on the circumference is 90. So if this angle is 90, guys, what is this angle? What is this angle? Now we know that if this is 90, from the angle sum property of a triangle, this angle should be 90 minus theta 2, because this angle is theta 2, so this should be 90 minus theta 2. So now what is 90 minus theta 2? So we know that 90, see from here also we can say one more relationship, that theta 1 is 90 minus theta 2, right? So now see this, I can write it as theta 1, yes or no? That means this angle and this angle are equal. Okay, now let us try to do some innovation here. Now let me say that I have a different chord here, okay, and let me say from the same chord PQ I draw a triangle, or I subtend an angle at some other point of the circle but on the same side of the segment. Now we have just learned that from a chord, if I subtend two different angles on the same side, they are going to be equal. So that means if this is theta 1, this is also theta 1. That means whatever angle I have here, I have it here. So this angle is equal to this angle. So this is a very, very important property. So from here I can say if this is 30, this is 30. Okay guys, so hope you have understood this. Now let me try to solve a different problem, okay, related to the same concepts of what we have learned till now. Now it is given that this is an external point P and I have two tangents PB and PA, and it is given that these two tangents, they intersect each other and the angle between them is 70. So they are saying find out this angle, find out this angle, find out this angle. All of you solve it, try to solve it. First of all, you tell me what is this, what should be this angle A, B and P, this angle. Yeah? Oh, already done. Okay. Others, do it guys. I want answer from all of you. Yeah? Very good. So guys, see here, triangle, this triangle P, B and A. I know that this side is equal to this side, right? That means this is an isosceles triangle. So this angle is equal to this angle. So let me say this is x and this is x. So we know that twice of x plus 70 is equal to 180. Angle sum property of a triangle. So from here I can say that twice of x is equal to 110, and from here I can say x is equal to 55 degree. So I got this as 55. So now what will be this? Yeah guys, try to solve this. So if this is 55, this is also 55. So what will be this angle guys? And what will be this angle? Simple, right? Do it. So now we have just learned in the previous concept that if I have a tangent, if I have a chord, then the angle that is subtended between the chord and the tangent is equal to the angle that is subtended by the chord on the other segment. So if this is 30, then the other segment, this will be equal. So here I have a similar situation. See here, this is a chord, AB is a chord, and this is a tangent. So if this is angle 55, then the angle that is subtended on the circumference should be equal to 55. So that means ADB we got as 50. Now what is the relationship between this angle and this angle? We know it, right? So if this is 55, what will be this? Yeah. Yeah guys? Fine. So ACB, we can just say that this is 2 times of 55, that is again 110 degrees. Okay. So similarly we can find this angle also. What will be this angle, guys? So we know that again this is an isosceles triangle ABC, right? From there we can find out, or we know that this is 90 degree. That is, we also know that CB is perpendicular to PB. So if this side is 55, this will be 90 minus 55. So in this way we can find out these angles also. So if we can find out this angle, we can find out this angle. So in this way we can find out all the angles here. So this types of relationships will help you to solve difficult level problems. So this is, I'm not saying this is a very difficult question, but from here you get to understand all the relationships and all the calculations between tangents and chords and segments that is subtended to that part of the segment, angle that is subtended on different parts of the segment as well as on the center. Okay guys? Fine. So now see guys, before I move on to more problem solving, so from now onwards I will solve a lot of problems. Now before I go for the problem solving session, so what we will do is, let me just tell you that there is a fast track revision course which is coming up, okay, for CBSE students, class 10, okay. So if you are interested, you can note down the link. So at the end of the session I will again show the link and show the details of this particular thing. So this is a fast track, that means complete syllabus will be revised, okay, and this will be a full term and full long course, okay. This will be continued till February, okay, and both for maths and science. So those who have missed out at the starting, you can join this course for now. So this is a long-term course but fast track, okay. So this is the link. You can note down the link, and this link will also be sent to you. Now at the end of the class or this particular session, I will say the details about this and course fees and all those are different things, but let us go to the problem solving for now. And also if you want some information and some relationship between this, so you can mail me, okay. So my mail ID, you can note it down, mridulgosh@vedantu.com. So you can mail to me for the details of this, or you can click on this link and you can see what are the details of this. Okay, so now let's start solving few numericals. Okay, so this question says AB is a diameter of a circle, P is a point on the semicircle, APB, okay, AH and BK are the perpendicular from point A and B to the tangent at P. Prove that AH plus BK is equal to A. Okay, so this is level 2 question. So by reading this question, you have to make the figure of this. So try to make the figure. After that I will draw it for you, all of you. So first of all, there will be a circle, of course, and try to read the question and try to draw the figure. So it is said that AB is the diameter of a circle. So let us take a diameter. So let us say this is the diameter. Okay, and let us say this is AB. Okay. So now say this is A and this is B. So now what they are saying is P is a point on the semicircle APB, and AH and BK are the perpendiculars from point A and B respectively to the tangent at P. Let us say that this is a point P. So now let me draw the tangent. Okay. So let me draw the tangent. So now what they are saying? Now they're saying that AB, AH and BK are the perpendiculars from point A and B respectively to the tangent at P. Okay, so then you need to prove that AH plus BK is equal to AB. So let us see what is the diagram of this. So it is something like this. Say AB is the diameter here. So I have not shown the solution. This is just the diagram. So AB is the diagram. AB is the diameter, and let us say this is P. So it's better if I draw it in this side because it is going to extend. So let me draw it in this way. Okay. So say this is the center. This is the diameter in this way, and this is the point. Right. Now this is the tangent. Now what they are doing is they are just throwing two perpendiculars from this. If you have drawn it in this way, you can leave it in this way, or if you have drawn the diameter on this side, then also it's fine, not a problem. Okay, so they have just thrown two perpendiculars on this particular tangent. Okay, and say this is the center. So we know all of them will be perpendicular. Now you see guys, say this is the center. Okay, now let us say this is, okay, let me see which is H and which is K. Yeah, so let us say this is H and this is K, and this point is P, of course. So now we know that if we join a radius to a tangent, this is going to be perpendicular. Similarly, this is perpendicular and this is also perpendicular. Now what they are saying is prove that AH plus BK, that means this length plus this length, is equal to AB, that means diameter. So how will you prove this? So let us say this is radius R, this is radius R, right, and this is also radius R. So what is AB guys? So AB is 2 times of R, right? Simple. Now let us see how to relate AH and AB. So that means what we can do is, let me draw it in this way. So let me try to extend this diameter. So what I have drawn guys is I have taken this diagram because it doesn't have space here. So let me try to show it here. So same thing. So what I have done is I have extended the diameter such that it touches any point on the tangent. Say this point is M. Okay. Now what I will do is, let me say that this length BM is equal to Z, and let me say AH, okay, AH is equal to X, and let me say BK is Y, BK is Y. So these are the 3 things which I have taken. Now let me try to find the relation between them. So what I need to prove, let us see. So what I'll do is, first of all, let me take this triangle MBK and triangle MAH. So now what is the relation between these two guys? What is the relation between these two? So see, this is also a right angle triangle. This is also a right angle triangle. So this is 90 and this is 90. What else guys? Now you see, we know that this is 90 and this is 90, and this length is equal to this length, so we can show that this angle is equal to this angle. Okay, right? So, and this angle will also be equal to this angle. Okay, so we can show this, and even if you don't show this, this angle is common in both of them. So by angle, or angle, 3 angles or 2 angles, doesn't matter. So by angle, we can say that these two triangles are similar. So if these two triangles are similar, so we can say that the ratios are in sides. The sides are in ratios. So I can say that y by x, okay, so this by this is equal to mk by mh. We can say that, guys? Yeah. Or we can say this is equal to, let me write it down. We can say that mk by mh is equal to mb by ma is equal to bk by ah. Right? Now put down the values here. So what is important from us is, let us say this is z. So let us take this value. So that is mb is z. So let me put this value z here. And what is ma? So if you see ma, this is nothing but z plus r plus r. So I can say ma is nothing but z plus 2r. Simple. And what is bk, guys? bk is y. Let me put it y here. And what is ah? ah is x. So from here, if I try to simplify this, what do I get the relationship of z? So let me see. So let me write it here. So I can say that zx is equal to, so I have cross multiplied this, and yz plus 2yr. So from here I get that zx minus y is equal to 2yr, and from here I get z is equal to 2yr by x minus y. So let me say this is point number 1. Similarly, in these two triangles, okay, in triangle MBK and triangle MOP, so I have taken these two triangles. This is 90, this is 90, and this angle is common. So again, these two are similar triangles. So from here I can say that MB by MO is equal to BK by OP. Okay, and that is equal to the other side, not required. So now what is MB? MB is Z. What is MO? MO is Z plus R. What is BK? BK is Y. And what is OP? OP is R. Now let me again cross multiply. So this will become ZR is equal to YZ plus YR. So now what happens is, now let me take this. So this becomes R minus Y is equal to YR. So Z is equal to YR by R minus Y. So now let me try to equate these two. So therefore from 1 and 2 we get that 2YR is equal to YR by R minus Y, and here X minus Y. So now this and this cancel. So now from here, if I try to find out, so I'll get 2R minus 2Y is equal to X minus Y. So from here I will get 2R is equal to X plus Y. So now what is 2R? 2R is AB. And what is X? X is AH. And what is Y? Y is BK. So from here I get that X plus Y is equal to 2R, or in other words, AH plus BK is equal to 2B. So in this way, guys, you can solve these types of problems. So here you need to know the relationship, that is triangle, similar triangles properties. Okay, and using this by the ratio of the sides, you can solve this particular problem. So not a very tough question. Somewhat simple question if you know the triangles thing. Now let us go for the next question. So this question, it says that in this figure there are two concentric circles. Okay, so this is one circle and this is the other circle. So now they are saying that the radius is, one of them is 5 and one of them is 3. So let us say this is 3 and this is the 5 longer one. So from an external point P, two tangents are drawn on both the circles. So on the circle with radius 5, I have at point A, on the other one I have at point B. Now they are saying that AP is equal to 12 centimeter. Find the length of BP. So how to do this, guys? This is simple, right? So we have two right angle triangles. So this right angle triangle, and we have one more right angle triangle, which is something like this. See here. Okay, see this. Here it is given that this is, say, A, P and O, and this is O, and say this is P and B. So now we know that this is 5 and this is 3. AP is given as 12. So what will be this, guys? So if you know this, right, so this is this square plus this square root, this will become 13, I hope. And if this is 13, now from here you can easily find out the length of this BP. So this is simple question. Okay, let me see what are the other questions which is kept for you. So okay, this is important, guys. So this question says, let a point A be one point of intersection of two intersecting circles. So let me take two intersecting circles. Okay, so this is this is a circle, and say this is a circle. And let us say that this point is A. So let A be one point of intersection of two intersecting circles with center O and Q. Let us say this is center O and this is center Q. Now what is said? The tangents at A to the two circles meet the circles again at B and C. That means if I try to draw a tangent to this circle with center Q, so it will be something like this. So let us say it meets, this tangent meets this circle, say at point B. Similarly, if I try to draw a tangent at the point A to this circle, okay, let me say this becomes, this point is C. Now let me change the color of this circle so that it becomes easier for us to say this circle is a blue one, so that we don't have confusion. So now I will say the blue circle and the red circle, okay, and say this is the radius. Okay, so how come this came this side? Okay, so say this is Q, is it fine? Yeah, this is the tangent to this circle. Okay guys, fine, this is fine. This should not be here. So let us say O is somewhere here. Okay, so this is O. This should not go from O. Okay, so now what they are saying is, let point P be located so that AO and PQ, AO, PQ. So you need some point P here such that AO, PQ becomes a parallelogram. So that means now they want to join these two lines. So let me try to join this. So they have joined this line, they have joined this line such, and now they want a point P such that this forms a parallelogram, right? So that means I will join it in this way, and this, so this is point P, and now this is a parallelogram. Now they're saying prove that this P is the circumcenter of triangle ABC. That means now you need to draw this triangle ABC. If you draw this triangle ABC, this point will be the circumcenter. Now what is circumcenter? Circumcenter is this point. If we draw a perpendicular on the sides, that will bisect the sides. So if we can prove that PO is perpendicular bisector of AB, that means this side of the triangle, and if I can prove that PQ is perpendicular bisector of AC, that means this side, and both of them meet at P, then of course the third one also will cross through this point, intersect this point. So we just need to prove that these are perpendicular bisectors. Okay, so we just need to prove that OP is perpendicular bisector of this side or this side of this triangle AB. How do you do that? So to do this, guys, you see here, let us see this triangle first of all. Okay, so if you see triangle OA, let me say this point is X. Okay, so OAX and triangle OBX. Okay, OAX and OBX. Now these two triangles, if you see, this side is equal to this side, right? OA is equal to OB. Now do we have any other relationship? We don't have. So we need to find some other relationship to find what is the relationship between these two triangles. So now let us see. Now guys, this is very important. If you see, this is OA, right? And if you see, what is OA? OA is the radius first of all, right? And this radius at point A, and I have a tangent at this point on this blue circle. So if you see, OA is perpendicular to AC. OA is perpendicular to AC. Yeah guys. So from there, I can find out something. I can find out some relationship. Right? So in this way, I can solve this particular question. So guys, you need to solve this and you need to send me the solution at mridulsh@vedantu.com. Okay guys, so try to solve this. Okay. Yeah, so try to solve this. These are the hints which is given. So with this, you see if you can solve this. Yeah guys, you might need some more hint. Okay, the hint is very simple. You see, if OA is perpendicular to AC, right? That means what? This is perpendicular. Similarly, I can also say that QA is perpendicular to BA. Now, how will these relationships help you? That is the only thing that you need to see. Okay. Now, you see guys, I will just tell you, OA is parallel to PQ because AOPQ is a parallelogram. See, this green one is a parallelogram, right? So, and here also QA, so this one is parallel to OP, this is P, right? So these two are parallel. Now guys, if this OA is perpendicular to AC, so suppose this is AC, okay, and if OA is perpendicular to AC, then a line which is parallel to OA, that means this line, will also be perpendicular to AC. That means OA is perpendicular to AC and PQ is parallel to OA. So PQ is also perpendicular to AC. So that means this angle is 90 degree. Similarly, AQ is perpendicular to AB. So OP is also perpendicular to AB. So if this is perpendicular, so I can say angle AOX or OXA, okay, this angle OXA is 90 degree. So this is a right angle, and in this right angle, so we got one angle equal, the other angle also we got equal, right? So this is an isosceles triangle. So if you see, this is O and this is B and this is A. So this side is equal to this side. This is 90 degree, okay, and this side is common. Okay, so from right angle hypotenuse side, you can say these two are congruent. If these two are congruent, this side, this part is equal to this part. So that means in this triangle, this part is equal to this part. So I can say that BX is equal to AX. That means what? That means PO has bisected this chord AB and also perpendicular to AB. So that means PO is the perpendicular bisector of AB. Similarly, we can prove that PQ is perpendicular bisector of AC. So if this is perpendicular bisector of these two sides, then definitely this will be a perpendicular bisector of the third side which passed through this point. So I can say this is the circumcenter of the triangle. So in this way we can solve this. Okay guys, now so I have already solved it. Okay, anyways, you can send me your doubts to this mail ID, and this is one more question for you guys. So note down this question. It says in figure AB is a chord of length 16 centimeter and the radius of this is 10 centimeter. So this is 10, and the tangents at A and B intersects at point P. Find the length of PE. So you need to find the length of this. So this is also, you can use the same concept what we have learned here. Okay, so this is what, this length is what you need to find out. What is given is AB is given as 16, OB is given as 10, right? Okay guys, so note down this, let me know when you have noted it. So that's all guys, and moreover, this is if you have any queries, I already gave my mail ID. So if you have not noted it, note it again. MRI last time, mridul.ghosh@vedantu.com, and any queries you can send to me, any doubts you can tell me. And this is also the link of the course. This link will also be sent to you. So I can also show you the page to this. So the page will be something like this. Okay, so this will be the page which will be, you know, you will be getting it. So let me just show this page to you. Yeah. So this is the page that you are going to land in once you click this. Okay, and here you can see all the details of this course. So go through this, and if you're interested, you can enroll in this particular course. Okay, so make sure you note it: https://courses.vedantu.com/CBSE and then dash class 10, that is 10 dash math dash science dash long dash term dash course dash direct. This is a long thing. You will get this link with you, pinned to you. Okay, so hope you liked the session and you have learned something. I was able to teach you something about circles and tangents, and hope you have enjoyed this session. So see you guys Bye bye.